Bienvenidos, Ushamdi, and welcome, CTS231, Section 841 students, for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4, or the Connecting Networks V6 course from Cisco Networking Academy, and this morning's packet tracer tutorial and solution set is going to be on our final packet tracer activity for the term and the semester. So this is it. We'll be looking at 8.3.1.2, which is our skills integration challenge that is going to pull all of the knowledge that we have acquired so far throughout this course, and we're going to get to employ all of that in a single activity. So let's go ahead and jump into the activity here. We've got quite a few things to configure. You can see we have our addressing table here, as we normally do. We've got some VLAN configurations and port mappings. And again, this is a comprehensive CCNA skills activity. The XYZ Corporation is going to be using eBGP and PPP for their WAN connections. We're going to have NAT, Dhcp, static and default routing, EIGRP for IPv4, inter VLAN routing, VLAN configuration, security configurations, including SSH, port security, switch security, and ACL. So we've got quite a bit going on here in this activity. And I love these activities because they really sort of simulate a real world scenario where you would be deploying equipment into a network. So let's go ahead and dive in here, and we're going to start right here with PPP, or the point-to-point protocol. Remember, Cisco's default encapsulation over serial links is HDLC, right? Or sometimes referred to as CHDLC. But we're going to be changing that default to PPP, and it looks like we're going to be doing some CHAP authentication here, and actually we're going to be doing some PAP authentication as well. So configure the WAN link from HQ to the internet, and so here is the HQ router. So let's click on this HQ router and bring it up. And the internet appears to be the link here that goes out. So headquarters data center, or I'm sorry, internet's over here to the left, is Autonomous System 65001. So this is the link out which we're going to be making these changes. So let's take a look and see what the link looks like now. So let's go from user exec to privilege exec with the enable command. And let's say the password is going to be class, and we'll say show run. And let's come down and take a look at serial 010. All right, so here's serial 010. You can see it says description link to ISP. We've got our IP address here. Now let's see what the status is. Show IP interface brief. And as you would expect, we are up down, because again, we're up at layer 1, so the router senses that there's a connection there at layer 1. However, at layer 2, which is where we would find HDLC and PPP, the link is down. So we need to bring that link up. We've seen this before, interface serial 010. Let's change our incap to PPP, and we should also probably get a point or two, and we do. We get a single point there. So configure the WAN links from HQ to the internet using PPP encapsulation and CHAP authentication. So we need to create a user, right? So we're going to say username, and the user is going to be all caps ISP. I'm going to say password Cisco. Now, very important here. Remember, what we cannot say is username ISP secret, secret Cisco. So let me pull this back. We can't say secret here because that would give us a type 5, right, an MD5 hash, and we can't hash a hash. So it has to be the password command and then the password of Cisco. And we should also see that we receive a point or two there. So we get a point, and that brings our link up. So now if we confirm show IP interface brief, I could also say show interface serial 010. Do show interface serial 010, right? And we see that we come up a little higher here. We can see that the encapsulation is PPP, right? And we can see that the line protocol is up and the serial interface is up. So we are connected. Everything looks good. So I should be able to ping the internet. So let's say do ping 209.165.200. I want to say it was 2. Maybe it was 201. And so while that's working there, we'll scoot back up here, let this finish. do show IP interface brief 201. Yeah, so let's say do ping 201. And my guess is that's the other side, and it is, right? So we've got connectivity has been established out to the internet. So now we're going to configure the WAN link from HQ to Newbie, right? And so this is new site B down here. We've got a serial connection, right? A serial link that connects the Newbie site to HQ. And we're going to do the same thing. You can see that that's probably out this serial 001 interface, and it shows up down as well. So we should be very familiar with. And let me check that again. Yeah, 001. That our end cap should be PPP, right? And now what we should see here is if I say do show IP interface brief, let's see if we see anything different. And we still show up, down. So what would the problem be? Exactly. So we've got authentication figured on the new B side possibly. We may need to actually go look at the new B side. But again, let's go ahead and make sure we put in here let's see, PPP, authentication, PAP, and we're going to say PPP, PAP, and let's see if they're asking us for this here. Configure the WAN link from new HQ and use PAP authentication. Create a user Newbie and the password of Cisco. So actually, we'll leave this here for now, and let's do this. We'll go ahead and say username is going to be Newbie, and they have that camel case there, so be careful. Capital N, capital B, and then password of Cisco. So we've got the right username and password in there, and now the question becomes, okay, the note, PPP is graded by the packet tracer. However, it must be configured before the link will come up. All right, so there it is right there. And before HQ and B. So let's check on new B. Okay, we can't get on to new B. So I'm going to do this because I'm going to assume that they are looking for us to go ahead and take the initiative here and say PPP PAP sent username HQ. Whoops, sorry. Sent username HQ password, and we're going to stick with Cisco. And let's see. Yeah, okay, so that brings us up. And so we're good. Now, you're probably wondering, if I were to say do show run on the serial 010, right, the link to the ISP, you'll notice I said in cap PPP, but I never said anything about the authentication here. And it came up, right? And so remember that you don't actually have to define it on both sides. That one side could be queried, but let's go ahead and say serial 010 and say PPP authentication, whoops, PPP authentication CHAP, right? And it still brings that line back up. All right, but the packet tracer activity brought it up for us, and then I moved on, but I want to come back and make sure that we get that in there. Okay, so we've got that in there, and that should do it for the PPP configuration. So now we're going to scoot on to eBGP. So configure eBGP between the HQ and the internet, right? And this should be some low-hanging fruit. This, as well as what we just did, you're going to see again on the hands-on final exam. So make sure that you are ready to go. So let's go ahead and say router BGP and HQ belongs to Autonomous System 65,000. The IP address for the BGP router, and we already know this, so we're going to go ahead and say neighbor is going to be 209.165.201.2, and then we need to make sure we put their remote AS in. Remember, this value that we're going to place in here, that remote autonomous system value, this is going to determine and dictate whether this is an eBGP peering, right, for external border gateway protocol, which means that we are establishing a peering with an autonomous system that is not under, typically not under your control, or is it an iBGP peering? Now, iBGP wasn't covered during the course. We did discuss it a little bit, but remember that this value will dictate whether it's an eBGP peering or an iBGP peering. If the values are the same, it's an internal border gateway protocol peering. If the autonomous system numbers are different, it is an external eBGP connection, and that's what we've been asked to do here. They point that out at the header here of this section with eBGP. And again, iBGP wasn't covered, but good to know that there is a difference there, and that this value is what dictates what that relationship will be like. And now we are going to advertise, and what are we advertising here? The 192, okay, so very simple here, right? So a simple network statement where we're going to say 192.0.2.0. Now remember, it's tempting with the network statements, all the IGPs that we've been working with, right? Remember, BGP is considered an EGP, right? An external gateway protocol. It is the EGP, okay? This is the protocol that's used to basically route everything on the internet. So we need to make sure that we're clear on the syntax. We don't say 0.0.0.255, right? It's not a wildcard mask, and we wouldn't say 255.255.255.0. We need to go ahead, and if I throw the question mark here, you'll see we actually need to say mask. Then put in the dotted decimal notation for the subnet mask, which is a /24. And that is the command that would be required. And that's probably going to get us a point or two, and it does. And that's the value that we're interested in, right? That's the network we want to advertise. So if I say do show IP BGP, you can see, right, and I'm glad that this is working as anticipated, that we have received a default route. And this is very common, especially in scenarios where we have a single connection out to the service provider. Because let's think about this for a second. Would it make sense, right? Remember that this internet router, right, or I should say this cloud here that we're paired with, this is the internet. Would it make sense with only a single egress point from our enterprise, right? And if you keep in mind here, so this is kind of our enterprise, is everything on that side of the red line. And then everything this way, this is the internet. So if we can only egress to the internet out a single interface, we don't have multiple connections to multiple service providers, does it make sense to say this internet, our ISP, should give me the full internet routing table so that I can make the best and most informed routing decision? And the answer is no, right? And it's probably obvious, but it's good to discuss it to make sure we're clear on that. With a single egress point out of the enterprise, the only thing that I need, whoops, pen stopped on me there. The only thing I need is this default route right here, because that is the only way for me to get out to the internet. So I don't need, there are no, best path decisions that the HQ router is going to have to make when going to the internet, because it has a single path, the only path out to the internet. So this is a wonderful way to deal with that. Simply tell the ISP, originate that default route and send that in to me. And that is all I will need right here, so that my data center, my HQ over here, my site B1, my Newbie, that all they need to do is get here to the HQ router, and the HQ router now has a default route. So for any routing information that HQ doesn't have, it will default to the internet, right? And this may change here. We're probably going to be doing some, what is it, EIGRP it looks like? Yeah, we're going to be doing some EIGRP, so we're going to see some additional routing information in our routing table. But again, if we don't have a longer, more specific match when traffic reaches HQ, it's just going to shove it out to the internet, which is what we want. So remember, there's no need to get tricky or fancy or anything like that. Have the provider originate that default route when we have a single egress point in our environment, because there is no decision that needs to be made. It's out this way or it's nothing, right? We're either going to default out here to the internet or we are not. We're going to have more specific information for our networks, and let's take care of that. So that's our eBGP configuration. We could also say, real quickly, do show Ip Bgp Summary, right? And this is going to give us some additional information here. It's going to say state prefixes received, how long the peering has been up, and we've got our neighbor's address, what version of BGP, not of IP, but what version of BGP are we running, and then the autonomous system number of our neighbor. Now, there's some additional information as we scroll back up here. The table version, right, is typically related to how many times or how many changes we've had in the table. And there is one thing that I'm looking for in here. Yeah, it doesn't use, obviously we've got a minimum number of routes. You can see we're using 632 bytes. But if you take a look at that and say, well, what if I had the full IPv4 routing table of 600,000 plus routes, then this becomes a little more complicated. So again, we see the information required for the eBGP peering, and so that takes care of that. So now we're down here at NAT. So it says configure dynamic NAT on HQ. Allow all addresses for the 10.0.0/8. And so here's what we're going to do. I'm going to come back to the dynamic NAT setup because I want to make sure, and because we're doing this on HQ, right? So as you can imagine, we're going to have that IPNAT inside command here and here and here and here. So 4 IPNAT insides, right? Because we're going to be, and maybe not for the data center. Let me check real quick. No, it looks like for only the 10s. So we're going to have some IPNAT inside statements and then a single IPNAT outside statement. And we'll have a standard ACL, and we'll tie that in with the dynamic setup here. And then we've got a pool of addresses that we're going to be setting up with a /29 mask. So we're going to come back to that. What I want to do first is I want to make sure that we get all of the connectivity on the internal network setup, then come back. And let's do our final step will be the NAT. So inner VLAN routing. So configure B1. So we take a look here at our diagram, and you can see that unless all of this down here behind Baker 1, unless everything down here is a single VLAN, and we're pretty sure that that's probably not the case, right? Because we've got admin, we've got sales, we've got production. Rest assured that we're going to be looking at a router on a stick scenario, right? To provide that inner VLAN routing. So let's go ahead and make that happen. So using the addressing table for branch routers, configure and activate the LAN interface for inner VLAN routing. VLAN 99 is the native. So we need to make sure that we are aware of that. So let's come up here to the addressing table for B1, and you can see all of our sub-interface. So all of our information is there. Let's dive in here and let's knock that out. And this should kind of be old hat right about now in terms of being very, very straightforward for us. We've done quite a bit of router on a stick. So we're going to go from user exec to privilege exec with the enable command. I think the password is still class. It is. So real quickly, let's say show IP interface brief. Let's see what we've got right now. So we've got gig 00 and gig 01. And my guess is we are, yep, gig 00. So let's get into global config. And let's go into interface gigabit Ethernet 00. And the first thing we're going to do is we'll start with a no shut, because that's going to bring this interface up here. And we're going to wait for spanning tree. We're going to configure everything, but while we're waiting for spanning tree to converge, we'll get all of our sub-interface configuration in. So now I can come back and say interface gigabit Ethernet 00 dot, and we'll put our first sub-interface in. Now, we've brought the first sub-interface up, but let's remember, it's important. What if I say IP address? If I go right away, I try to get the IP in here, and let's say 10.1.10.1, 255.255.255.0, because it's a /24. And this is going to be our default gateway for the hosts that we have coming in behind Baker 1. So all of this traffic here that we see coming through B1 switch 1, this would be for VLAN 10. Now, if I try to do this, we're going to have a problem. What's that problem going to be? Yeah, exactly. I don't have the encapsulation defined on the sub interface. And this is critical because remember, it's this encapsulation that is going to allow, right? We're going to be putting that tag of VLAN 10 on the traffic as it transits this trunk port right here. And this will be a trunk port between Baker 1 switch 1 and Baker 1 router. That's a trunk port. And when we go across and we egress from Baker 1 switch 1, we're going to have an 802.1q tag. And you can see right here, IEEE 802.1q. We're going to have an 802.1q VLAN tag on that frame so that when that traffic arrives at gig 00, the physical parent interface, that it can make the decision, right? It can look at that framing information and then say, aha, this is going to the sub interface that has the incap.1q10 command on it, right? Because VLAN 10 traffic would have, VLAN 10 traffic is going to have an 802.1q VLAN tag that's going to represent VLAN 10. And so that is going to correspond to this interface here. Now remember, very important, that this sub interface number, and let's give ourselves a little more, whoops, not that much. Let's bring it back down a little bit here. So I apologize here. So let's remember, I'm trying to get it into the same frame, but it might not be possible. Yeah, so remember that the sub interface number does not need to match that statement right there. Okay, but you would be crazy not to do it. So remember, if you've got to go back and troubleshoot, or more importantly, if you've got somebody that you work with who is going to have to follow you, maybe you're out sick, maybe you're on travel, maybe you're on vacation, whatever the case may be, if somebody else has to follow your work, you want to make sure that you're making things as easy as possible for them to troubleshoot if you're not there. It's also probably going to save you from an unwanted phone call, right? So make sure that you make things simple. So the sub interface is gig00.10. It's going to correspond to the admin VLAN, VLAN 10. So we're going to say incap.1q10, and we're going to hit enter. And now I can put the IP address on there. Again, the router kind of helping you protect yourself against what would be a fatal mistake, because it's not going to work if we don't have that right. So let's say interface gigabit 00.20, and again, incap.1q20, and then IP address 10.1.20.1, and let me double check that. Yep, 255.255.255.0. Interface gig 00.30 is my guess. Yep. And incap.1q30, and then IP address 10.1.30.1, and let me double check that. And then we're going to get our native VLAN, and I'm going to make sure I don't forget this as I did earlier in the term where I came in here and I said int gig 00.99, incap.1q99, and I hit enter right here. Now remember, we've been told that VLAN 99 is our native VLAN, and what that means is, remember, the purpose of the native VLAN is that traffic coming across the trunk, any untagged traffic that arrives here without a tag is going to be tagged. It'll be given the tag of the native VLAN, right? And I should say it'll probably happen right there as the traffic's flowing this way, that traffic with no tag, right, is going to be tagged with VLAN 99. That is our native VLAN. And so we want to make sure that we call that out on both ends of this trunk. So incap.1q 99 native. And let's see that, yeah, that would have cost us a point had we left that out. Now let's get our IP address in here, which is going to be 10.1.99.1. And then we've got our subnet there. So spanning tree obviously is converged, and that is the inner VLAN configuration. So do show IP interface brief, basically a router on a stick. We can do a quick check here. Everything looks good. All the interfaces are up. All of the IP addresses look good. We've got our native VLAN defined. And I'm assuming, so the config is locked there. So we're not going to get a chance to peek at the configuration here on Baker 1 switch 1, but that's okay. We're confident that things look good here on the router. So that takes care of the inter VLAN routing. Okay, let me make sure. Activate the LAN interfaces for inter VLAN routing. So we're good. So static and default routing. We're going to configure HQ with a default route, and let's see how they want us to do this. So it doesn't look And maybe we do advertise that into EIGRP. It's not clear if that's what we're going to be doing, but let's see here. Configure HQ with a static route to Newbie LAN. Use the exit interface as the argument. So here's the Newbie LAN. If we take a look, you can see they really help us out right here, right? They give us the network that we need, 10.4.5.0/24. So we need a static route here. So we're going to come back out. We're going to say IP route. And remember, it's not a static default route, so we're not quad zeros here, right? Remember, I'm saying that my route to get to the 10.4.5.0, and then is it a wildcard mask? No, it's the prefix. I'm sorry, the net mask in dotted decimal notation. So my route to get to the 10.4.5.0, 255.255.255.0 is going to be out. And I'm hoping that we've got it. I'm pretty sure we have a show IP interface brief here since I've got the command Q. Oops. 10.4.5. Which link is that? Newbie. All right, so interesting here. It's showing the serial 001 to Newbie. And maybe, okay, so they must just be advertising that network out to us down there. Let's see what we have over here. All right, no information for Newbie. So here's what we're going to do. We're going to stick with that, and we're going to say, basically, we'll put the interface in here, and we'll say, whoops, and we will say serial 001. I was thinking that I had some information earlier that gave us that, and I do not. So, all right, so there's our static route statement. I don't see anything that we can ping down there. Can we get on to anything down here? All right, so we can hit the PC. So let's check our work here. Let's go ahead and say ping, and I'm going to ping the HQ routers interface, serial 001, do show IP interface brief. And now that there's a static route to get back to me, 10.255.255.253, ping 10.255.255.253. It should work. We've got connectivity. All right, fantastic. So everything looks good there with that first static route definition. Okay, so HQ with the static route to the Newbie LAN, use the exit interface. Configure Baker 1 with a default route to HQ. Use the next hop IP as the argument. So HQ serial 000 is 10.255.255.1. And let's come to Baker 1 here, and we're going to say, and it's interesting, I thought that maybe they would have us do this with EIGRP possibly, right? With a redistribute static here off of HQ, but it looks like we're going to be hard coding these in with a default route. So here's our quad zeros and the IP 10.255.255.1. And we should see a pointer 2 for that, and we do. Okay, so we've got our static and default routing taken care of. So now EIGRP routing. We're going to configure, and there's this ominous word, optimize, HQ and Baker 1. So let's see what they're talking about when they're saying optimize here with EIGRP routing. So HQ, and we'll start at HQ. All right, so we're going to use Autonomous System 100. Remember EIGRP, right? Router EIGRP 100. And we have a few things that we can choose from here. So always a good idea. We'll say no auto summary, although I don't think that's going to garner us any additional points, but let's make sure we've got auto summary turned off. And it says disable EIGRP updates on appropriate interfaces. So if the scenario is we're going to be configuring EIGRP between HQ and Baker 1, right, it would be easier for me to say passive interface default because there's only a single interface which I am going to say no passive interface. So it's easier for me to do it this way because it's going to be 2 commands, at least that's what it appears now. We'll see how things progress. So let's watch our score and see, was that what they were looking for? And it was. That was a 2-pointer. So passive interface default. Now we're going to say no passive interface serial 000 because it's out that interface that we're going to be running EIGRP. And we're not awarded anything there, which is a little concerning, but we'll see how things go. So we had no passive interface serial 000, And they really don't give you much information other than that. So let's go ahead and get our network statement in here. Do show, we'll say do show run. I think it's a /30 on the serial 000 link. Let's check, and it is, okay. So we'll come back with network 10.255, oops, sorry, 255.0. And now remember, we're dealing with EIGRP here. We got to put in our wildcard mask 0.0.0.3, right? Because that represents a /30's wildcard mask. And so we did see a bump on points there. And so given what they have provided, use Autonomous System 100, disable updates where appropriate, and we've got it running on this interface, that's pretty much it. Because, again, there's a default route here on Baker 1, so it's not going to happen via EIGRP. So now we'll take care of Baker 1. All right, let's see. I always get a little suspicious when I see the optimize word in the instructions because that carries lots of different meanings for different folks. Okay, so router EIGRP 100, we're going to say passive interface default. I'm going to say no auto summary. And then the only thing left here is to show IP interface brief. Let's make sure we get a listing here of everything. All right. So here's where it's going to become interesting. We know we need the network statement for the 10.255.255.0, 0.0.0.3, right? So we know that we need that. And we've got our passive interface default in here, so we're going to say no passive interface. And which interface is that? Serial 000. So we're going to see the EIGRP neighborship pop up, right? So that's good news. And now we're going to no passive all of the sub interfaces here. So we're going to say no passive interface gig 00.10. And let's see, are we getting any points? Okay, so we actually just lost a point. And so Andrew had brought this up in a lab scenario. I can't remember the number, maybe 82112, where the optimized keyword showed up. And when you approach it like this, the scoring engine did not appreciate that. So here's what I'm going to do. I'm going to come out, I'm going to say no, router EIGRP 100. And I'm going to approach this. We're at 26 points. So router EIGRP 100, right? Because again, there's oftentimes more than one way to do things. So we get a point for that, right? That's kind of straightforward. I'm going to say no auto summary. And here's what we're going to do. Because on the optimize, let's see, passive interface default, did that earn us any points? Because I think it did. So they gave us 4 points for that. But then they didn't like the fact no passive interface, serial 000, and then did we lose points for that? Okay, we didn't. Okay, so we're good here. And I think what I may have done now that I think I said no passive on the gig interface. I didn't want that. So now the next question becomes, do show IP interface brief. And I apologize for that little, so the confusion there was I actually typed in the wrong interface by mistake when I said no passive interface, and then we lost points. As we should have, right? As we should have, because we do not want EIGRP hellos flooding out here into this switch, then only be sent to all of the other switches to get that network or that traffic to hosts that aren't actually speaking EIGRP. So that was a mistake on my part. We've got the no passive interface in, so we're good here. So now the question becomes, are they looking for individual network statements for the 10.1, 10, 20, 30, and 99, or are they looking for one single sweeping statement, which is what they were in that previous activity, although that is, I guess, optimized from a configuration stanza standpoint, because we're going to have a single statement as opposed to multiple statements. But let's see what it is that they might be looking for here. So let's see if it's the individual statements. And do we move off of 33 points? Or 31 points, I apologize. We don't. So that is not what they're looking for. And so that's what I had suspected. So my guess is that they're also not looking for, where's that 255? Or do I have that in there yet? Let's take a look at our EIGRP config section here. Okay, so no network statements are in here. So this is my guess, is that they're looking for the same thing, right? The network 10.0.0.0.0.255, that is what they're looking for, like just the whole /8. So anything that's a 10, we're going to run the EIGRP process. It brings the neighbor up, and we got a single point for that. So that is definitely interesting. So I thought we may get more than a single point. So that is all that's required. And the reason that they're saying optimize here, right? It's not being optimized from an EIGRP process perspective, right? But from a configuration stanza perspective. And that's where that statement that optimize means different things. So you can see we get away with a single statement here as opposed to what would have been 5 network statements. We can do a single network statement. We have a single no passive, and we have that single passive interface. So that is optimized from the configuration stanza perspective. But the best practice is to not leave it wide open like this. Because what happens if someone plugs a router in here and they use the 10.10.10.0/24? Exactly. That interface is now going to be sending out EIGRP hellos. And you may not want that. So again, from a configuration stanza point, yeah, it's optimized without a doubt, but not from a sort of configuration topology perspective, let's say. So that's EIGRP. So now we get down into VLANs and trunking configurations. Logging to the console is turned off on Baker 1 switch 2 so that the native VLAN mismatch messages don't interrupt our config. And we could say logging console, but let's see how this works. So configure trunking in VLANs on Baker 1 switch 2. So here we are on Baker 1 switch 2. And I'm definitely going to MC this as the text, my guess is going to be tiny, and it is, so we'll definitely walk through this. So we'll go from user exec with the enable command into privilege exec class as our password. And so here we are logged in. I'm going to say show interface trunk to see what we're working with. We can see we've got a negotiated 802.1q trunk. Dynamic auto is the mode. Native VLAN is 1, and we know that that's probably not going to be accurate. So create and name the VLANs listed in the VLAN configuration and port mappings table on Baker 1 switch 2. So here's the VLAN configurations and port mapping. So let's go ahead and get everything configured here. Again, some straightforward stuff. So VLAN 10, and we're going to stay case sensitive here on the name. That's typically what they're looking for. And we say admin. And yep, so we're basically going to be getting a point for each of these, and then VLAN 20, and the name is going to be sales, and then VLAN 30, and the name is going to be production, and then VLAN 99, and the name, and this is an interesting name, MGMT ampersand native, and then VLAN 999, and the name is black hole, and that's what we're going to be putting our unused interfaces into that VLAN, and that's what we want. All right, so let me double check here, and I'm assuming they're going to want SVIs. Let's check and see. Create and name the VLANs. Listen to the VLAN on B1 switch 2 only. Configure the VLAN 99 interface and default gateway. Okay, so that, it looks like we're going to do that single one. So, and when they say interface, right, when they're talking about a VLAN, and they say configure the VLAN 99 interface, you say interface VLAN 99. And that, by definition, is the switched or switch virtual interface, the SVI. And we're going to be using this for all of the management work that we would do on the switch, right? So for management traffic, we're going to be using VLAN 99. And the reason that we only configure an SVI for VLAN 99, and this is one of those scenarios where sometimes students get confused is the question comes up, well, why am I not creating an SVI for all of the other VLANs? And that's a very valid question. And here's the reason that you would not do that. Because we're talking about switch, we're talking about this switch right here, right? VLAN 99 is the management and native VLAN. If I put an SVI on that switch for VLAN 10, which is in the admin VLAN, right? Sure, the admin, this workstation would be able to ping it, and that would be great so that we could say we have connectivity. But here's the other thing. Now, all of the nodes on VLAN 10 who could be end users that don't have your best intentions at heart can now start trying to SSH or telnet into the switch, because that's going to give them the ability to try to do that, right? So we want to limit that visibility. We want them to only see the VLANs, and we only want the management VLAN 99 to be accessible via SSH, which I'm assuming we're going to be doing a little further on down here. And so that's why, right? Because remember, the admin department doesn't need to manage your switch. The sales department doesn't need to manage your switch. The production department doesn't need to manage. It's the management VLAN, and whatever management VLAN. And if you've got we have inter VLAN routing set up here, right? So maybe we do an access list that says only nodes coming in from the 10.1.99.0/24 with a source IP of something in that subnet, only they can connect into the switch. So we want to protect these switches, right? We don't want to let end users who may be bored out here in the sales department and have nothing better to do but to try to see just how good of a network engineer and administrator you are, right? And so that's why you don't create all of those SVIs on this access layer switch down here. We wouldn't do that. All right, and again, that's just one, that's just one reason as to why you wouldn't do that. So back here to Baker 1 switch 2, we've got all of that configured. We're in the interface VLAN 99. Out of habit, I'll say no shut. Typically, it comes up. And the IP address, and I should probably scoot right back up here, is going to be Baker 1 switch 2, 22, 10.199.22. So IP address 10.1.99.22. We know that we're in a /24. Right, very straightforward on our subnet masks here today. And where are we at? Configure the interface. And the default gateway. And again, very, very important. So I'm going to say IP default gateway. And the default gateway is going to be the 10.1.99.1. And let me double check that. 10.1.99.1. Right, remember, it's this sub interface here on the branch 1 router. That is the default gateway, right? And so we're saying IP default gateway on this layer 2 switch, so that for admin, for control, or for not control plane, but for the management plane traffic, that any traffic originated by the switch. So in other words, when the switch says ping something, that is the default gateway. When the switch says, if you're on the switch and you say SSH to some IP address, or you say telnet to some IP address, the default gateway that that traffic will use is 10.1.99.1. That is very different from when someone on the admin PC down here says ping to something, right? Because remember, the PCs, they are not using that IP default gateway value on the switch. They're using this value that is configured on the PC that sends them where? Exactly, to their next hop default gateway, which is the sub-interface on the branch 1 router. So when we go in, and this is an important distinction because a lot of learners new to networking, when they see this command, don't realize that that command is not saying, oh, admin PC, sales PC, production PC, if I don't know where to send your traffic and I'm Baker 1 switch 2, I'm going to send it here to 10.1.99.1. That is not what happens. remember, there's a very, very important distinction here that this statement that we've just put in, the IP default gateway 10.199.1, that statement is for traffic originated on the Baker 1 switch 2, B1S2. So think of it like this. Here's the analogy. When I look at the admin switch, the admin PC, and I see, and it looks like its information is gone here, and yeah, we're going to be doing DHCP possibly. So again, but the default gateway statement that I put on the PC to tell it to come to the sub-interface up here on branch 1, B1 router, think of it as we're treating the switch just like we do the admin PC, is that the switch as a host for its self-originated traffic needs to know, hey, if I don't have a specific route here for this management traffic that I'm generating for Telnet or for my SSH or for my ping or for my trace route, where would I send that? Where's my default gateway? And that's what this statement is all about. Again, it's a super, super important distinction that needs to be made there, because this causes so much confusion when learners see that statement and then assume, oh, well, for all of my PCs down here, that's my default gateway. No, it is not, right? It is not. All right, so we've got the IP default gateway statement in there. Set the trunking mode to on for F01 to F04. So here we're going to say interface range range FA01-4, and we're going to say switch port mode trunk. So do show interface trunk should now show not auto, right? And we don't see the N for the negotiated here. We see on mode, and that's what it was looking for, right? To change it to on mode. Now, another typical command that you would put, and let's see if they were waiting for this. What command do you think I'm getting ready to enter here? Exactly. If I've hard-coded it to on mode, is there a reason for the dynamic trunking protocol, DTP, to be running here? Is that going to be required? Yeah, no, so we don't need that here. So what we could say is switch port, no negotiate. Now, we're at 45 points. I'm curious to see if they were anticipating that that was going to be entered, or maybe they're asking for it later on. No. All right, so we'll leave it on there because it's not going to hurt anything, and it didn't take any points away, but it didn't add any points. So assign VLANs to the appropriate access ports, and this is on Baker 1 switch 2. So for that, we definitely have to come back up here, right? And so we're already in the interface range here. So what would we say? Switch port, trunk, native VLAN, VLAN, and what is our native VLAN? 99. And so for that, we should probably see something. We do, 4-pointer there. So we've got the trunk ports in the native VLAN set properly. Now let's get into interface fast Ethernet 06, where we're going to say, and I'm actually going to do, let's see what they've got on there. Do show run. Let's see what's on here. All right, so 6, 11, yeah, they're totally blank. 16, yeah, so these are all blank. So here's how I'm going to approach this. I'm going to say switch port host. And actually, is that command available in Packet Tracer? It is not. So here's what we'll do. We'll say switch port mode access. And I'm assuming they're going to be rewarding us. Yeah, they are. So switch port mode access. And before I continue, that switch port host command, what that is, right, is, let me get a switch up here. And preferably a switch that I'm not working on. So on this switch right here, if I was to go into, let's say, show run interface fast Ethernet 101, and you can see that it shows it's shut down. Now, if I go into the interface fast Ethernet 101, and I say switch port host, a number, this is what we refer to as a macro, right? A macro is when you go into, I'll give you an analogy of something that you've seen before. A macro is a command that you run that actually maybe runs more than just one command behind the scenes. So spanning tree, when you go to set, and I think we're going to be doing this here shortly, when you go to set a switch as the root bridge for a VLAN or a set of VLANs, when you go in there, you can say spanning tree VLAN whatever. And here, let me actually run the command here. So if I was to say spanning tree VLAN 1, you'll see we've got a choice here of root or priority. So if I was to say root primary, that is a macro, because I'm not actually typing in the value that I would have typed in if I would have said priority and then set the priority to 0. Because for VLAN 1, that is going to make this switch, again, assuming that all the other switches it's connected to have default settings, and that would be 32.768 across the board right now for VLAN 1. If I said this, that is hard coding the priority to 0 for this switch for VLAN 1. It becomes the root bridge. When I do that, what value is put in there? It's at 2, and I can never forget, it's 24567 or 24576. So I would say spanning tree VLAN 1 root primary do show spanning tree, and let's see, yeah, there's that, or yeah, 24567 or 24576 is the value. I apologize because we're adding 1 in there, right, for that system extension ID. So what it does is it kind of goes behind the scenes and checks and sees what the other BPDUs are for the other switches that I'm connected to. And then it's going to make an adjustment, and based off of the other BPDU values from the other switches, it's going to choose a lower value, right, 24576, to ensure that I become the root bridge. But that's a macro. And a macro, again, it's something that's doing more than one thing behind the scenes. So back to Fast Ethernet 101. When I come in here, do show run interface Fast Ethernet 101, you can see the port is just shut down. So I'll say no shut. We'll bring the port up. Now, I want to go ahead, and there's a couple things I want to do, right? For an access port. And again, we're defining an access port as a port into which we have a host or maybe a server connected. So what would I want to do? I would want to say switch port mode access, right? Because I'm not going to leave it as the default. So I'm going to say switch port mode access. I'm going to say switch port VLAN, whatever VLAN it would be, and we'll say VLAN, oh sorry, switch port access VLAN 10. And I'm going to say possibly spanning tree port fast. I'm also going to say spanning tree BPDU guard enable, right? So that if I get a BPDU off of a host, which I should never get, then I would shut that port down, right? I would error disable the port. So you can see I had to type a whole bunch of commands in here to do that. So here's a much easier way to do that. I can simply say switch port host, and it tells you what it just did. It sets the mode to access for the port. It turns port fast on for you auto-magically, and then it disables if you were to have any kind of channel, ether channeling setup. It's going to disable that. So now let's take a look, and let's actually do it here. We'll say do show run interface fast Ethernet 102. I'm going to pick another port. So interface fast Ethernet 102. If I were to say no shut and then switch port hosts, or switch port host, sorry, I didn't mean to say the plural there. Switch port host, take a look at what it did. It did the access command for me, the switch port mode access. It did the spanning tree port fast. So now all I need to do is come in and say spanning tree BPDU guard enable, and then switch port access VLAN 10. Right? So it's this macro that's going to work a little quicker for you than if you were to enter all the commands in individually. All right, so back we come here. So then we're going to say switch port access VLAN, and we know that Fast Ethernet 06, which is the port that we are in, should be in VLAN 10. And we know that that's probably correct. We'll see, yeah, we ended up with a point for that. And so I'm also going to put on here spanning tree BPDU guard enable, and I'm going to say spanning tree port fast. So now let's take a look at what FA06 looks like. Yeah, that's a much better configuration, right? And that's the type of configuration that you're going to be looking for. And maybe we've got a little port security. It looks like we do, so we'll get to that shortly. But again, that's a very solid initial configuration for an access port. So next in line is Fast Ethernet 011. You can see we've got nothing here, so interface Fast Ethernet 011. So switch port mode access. And we'll say, I don't think I said no shut, but that port should be up. So then we'll say switch port access VLAN, and for fast Ethernet 011, it's VLAN 20. And I'm going to go ahead and throw in here the spanning tree port fast and the spanning tree BPDU guard enable commands, right? We want to make sure we get those on there. This is best practice stuff that you're going to want to include in the real world. Now we're going to go into interface fast Ethernet 016. I'm going to say much the same thing. Switch port mode access. Switch port access VLAN, and this is going to be 30. And then I'm pretty sure it's up, so we'll say no shut anyway. And then again, our spanning tree port fast. That way we skip the listening and learning. We go right from disabled to forwarding. And then, what did I say? Spanning tree, BPDU guard enable. That way, if we receive a BPDU on this port, and a BPDU is only would be generated by a switch, we're shutting down, right? It's game over. We're going to air disable ourselves. All right, and we've already taken care of the native trunk port, so we're good there. So that should be it for that. Disable all unused ports and assign the black hole VLAN. Now, you'll notice it doesn't say to set them as access ports, but my guess is there's going to be some points for that. So FA01, 02, 03, and 04 are the trunk ports that we've got here. And then the 3 ports that we've just used, 6, 11, and 16, those are all in use. So it's going to require some ingenuity on our part here with our range command, and I'm trying to get this to, yeah, let's leave it. We'll do this. For this command, we'll leave this here. I'm going to say do show IP interface brief, hoping that this is a 24-port switch. And it is. All right, so all unused ports, those are currently down right now. So let's go ahead. We're going to say interface range. So fast Ethernet 0/5, comma, we're using 6. So 1 through 4 we're using. 5 we are not, so that's our first unused. 6 we are, but then we're not using 07 to 10. We are using 11. We're not using fast Ethernet 012 to 15. We are using 16, and then we're not using 017 to 24. Now, in addition to that, we are not using gigabit Ethernet 01-2. So crazy range statement right there, right? Definitely forcing us to, because if you were to have to sit here and do each of those ports individually, you're going to be here for a while trying to do that, right? So we get that range in here. And I'm going to say shut. I'm going to administratively shut these down. Now, it's not asking for that, but I'm wondering if they're going to want that. And again, that's a best practice. We want to shut that down. So I'm going to say shut, and did we get anything for that? A single point. So they were looking to have those shut down, right? So we're going to say shut, and I'm going to say switch port mode access. And it didn't say to make them access ports, but let's see if that's what they wanted. And did we get a point for that or not? No, so they didn't want that. And then I'll say switch port access VLAN, and the black hole VLAN is 999. And let me double check that just to make sure. Yep, 999. And so we should see some reward for that, and it's a single point. All right, so not many points for quite a bit of configuration. So now when I say do show IP interface brief, only the ports that we're using, right? Only the ports that we're using. VLAN 99 is up, FA016, 11, 5, and wait a minute, I'm sorry. It looks like, I'm sorry, 6 is up, right, and 5 is down, and then 1, 2, 3, 4 are up. All right, so we should be good to go right there. Now we've got some port security concerns here. So we're going to establish the following security parameters here for Baker 1 switch 2. Disable all unused. Oh, it did say disable. I'm sorry. So we did need to shut it down, but it didn't say make them access ports. All right, so allow 2 MAC addresses to be learned on the port on the access ports, right? So this is only going to be 6, 11, and 16. That's who we're interested in here. So let's make that happen. So interface range, fast Ethernet 0/6. I'm just taking one last look up here. fast Ethernet 011, comma, fast Ethernet 0/16. Those are our access ports. So we're going to say spanning, I'm sorry, spanning tree, I apologize. We're going to say switch port, port security. So we need that right out of the gate. We have to have that. That basically says, hey, I'm interested in running port security on these ports. Now, at this point, we have the default settings. And so what are some of the default settings? Well, when we say switch port, port security, MAC address, sorry, not MAC, I don't want to do the sticky yet, maximum, we'll talk about that first. So the maximum, you'll notice we didn't type anything in, but the maximum by default is a single MAC address. But here, we're being told allow 2 MAC addresses to be learned. So I'm going to say switch port, port security maximum 2. And you notice it said learned, so that the learned addresses can be added to the configuration. Well, that is switch port, port security, MAC address, and we could hard code it, or I could say sticky. Now, sticky means that it's going to learn it auto-magically for us. And when I say do write mem or copy run start, the MAC address that has been learned is now going to be saved in the running config. So if I reload this switch, the MAC addresses that have now just been learned are also going to be saved. Now, allow 2 MAC addresses. Remember, the default was 1, and it says set the port to send a message if there is a security violation. So we want to send a syslog message. However, traffic is still allowed from the first 2 learned MAC addresses. So this is our violation policy. So I say switch port, port security, violation. We do a question mark. We've got 3 choices here. Protect, restrict, and shutdown. The default is shutdown. So if I came into this port and I did nothing but say switch port, port security, or this group of ports, this range of ports that we're working with, if I said switch port, port security and hit enter, I would be allowing a single MAC address by default, and I would be allowing the shutdown mode, which means the port would be shut down. And we don't want that. We're being told the requirement is that the 2 addresses that have been learned, if there were 2, and the traffic is to be allowed to continue to pass. So that brings us to either protect or restrict. And this is the difference between protect, or one of the differences between protect and restrict, is that protect is not going to send a message if we've got a security violation. Restrict will. So we say switch port, port security, restrict, and we should also see that, yeah, that was a 3-pointer, right? So we receive the 3 points. So what do the access ports look like now? Let's do a do show run. We'll take a look at 6. And boy, that is a very solid looking access configuration, right? Very, very solid. We're in really good shape with that configuration here and in the real world. So that takes care of the port security configuration. So HQ, we're going to configure HQ to use SSH, and let me go ahead and minimize this here. We're going to configure HQ to use SSH, and I'm reading the requirements here, so 2048. All right, so let's go ahead and get back onto HQ. So there's a few things that we're going to have to do here, and this is one of the things that's very, very common that gets overlooked. So it says set the modulus to 2048. Okay, well, and I'm going to walk us into a mistake here. So if I was to say crypto key generate RSA and hit enter. Now, on a real Cisco router, right, remember, you can get away, right, we can weasel here, and I know I've got one that's probably already up. There we go. So, whoops, if I say enable to get to privilege exec, go to global config. If I say crypto key generate RSA, I can put all of what I need here, my modulus 2048, right? I can get that all here and hit enter. And then we get the error that we're about to see over in Packet Tracer. We have to define the domain name first. So remember, because it's going to be used, right, with the SSH key. So IP domain name, domain dash name, and you can see then we put the domain name in here, which is going to be, and boy, they went all out on a domain name, ccnaskills.com. So that is our domain name, and again, we get a quick point for that. So now I can come back and say, and actually I pulled the command back without getting the error. So crypto key generate, right? So packet tracer is going to, oh, actually, hold on. Maybe I overlooked, okay, no, crypto key generate RSA. The packet tracer is going to force us into the interactive configuration. So I'm going to say 2048, and let me make sure. And there we go. And that would be much quicker. That's, again, packet tracer kind of hiding the gory details. If I were to say IP domain dash name ccnaskills.com, whoops, .com, and then I rerun that crypto command, right? You can see that I don't get the prompt back right away, right? Depending on the model of the router and how powerful the CPU is going to dictate how long you sit here. And you can go all the way up to 4,096 bits. I don't recommend that on ISR G1s, irrespective of how good you think the CPU is there, right? And again, on some newer switches, if I was to rerun this command and say 4096, this could take a while, right? And we're not going to wait for it. In fact, we'll come back, and let's lower this down here. And I want my desktop back. All right, so we've got our keys configured. We've got the domain name set up. The username is admin, and the password is admin only. And again, you can see they don't say, do they want us to use secret for an MD5 hash, or do they want just the password, which is going to be a type 7, very easy to hack. So let's feel our way through this here. And I'm just making sure the version that they're going to let us, they want us to change the version and all of that. All right, so here we go. Let's say IPSSH version 2. That's the first thing that we're going to do, because they are asking for that. We've got to retry. So let's say, whoops, username and admin, and let's go with password first, is admin only. So right now we're at 71 points. Do we get a point for this? We do. Pretty scary, right? So they wanted us to just go ahead and put it in there, and it would end up as a type 7 if we enable and I'm drawing a complete blank all of a sudden on the service password encryption. So if we put service password encryption in here, we'd get a type 7. Right now, what do we have on the HQ router? Where's our username? Okay, so service password encryption's on. So we have a type 7. And again, remember, these are literally cut and paste easy to crack. So you probably don't want to use the type 7s. You would want to use, well, what you would want to use is the script. And real quickly, and since we're here, let's talk about this again. And you can see, right, are these keys done yet? No, this is still running, right? So we still got stuff going on here. So CCNA security course, which I'm going to be teaching in a couple of weeks, actually, at University of Maryland University College. This is going to be something that comes up often, right? So if I go into global config and I say username, admin, I've got some choices here. And if I do a question mark, you can see, not to get too far off target, but this is important, algorithm type, right? So I could say secret and get a type 5, but you should no longer be using type 5s. I should say algorithm type. You can see we could do a type 5, sure. Not recommended. Script. This is where it's at. This is a type 9 password. It is kind of based, it uses, behind the scenes, it uses SHA-256, but it's even better than SHA-256. It's going to protect you against all kinds of attacks. So let me go ahead and say script, and then it's going to say, specify the secret password here, or the passwords. Let me just say ABC123. And let me rerun this command, and I'll put in here, just so you can see, a real quick, we'll say SHA, and then we'll do MD5. MD5, right? So now I'm going to say do show run, include username. And this is going to give you, oh yeah, didn't even realize I wasn't changing the username. So real quickly, there's our MD5. Let me come back to SHA. Sorry about that. Let's get the usernames in here. And then we'll come back to the script. And then this is going to give us something much more interesting to look at when I run the following command. My apologies there. And you can see, right, take a look at the difference in the hash between type 5, type 8, and type 9. And if I was to use a real password, the 9 would be out. Just a few more characters out here. It would be even more convoluted. So type 9, script, is what you want to use. But back to this activity. Let's keep things on track here a little bit. We're using type 7s here. Okay, we're going to have to just accept the responsibility. Now, we've got the username password. So SSH, only SSH should be allowed on the VTY line. So let's go ahead and say line VTY 015, transport input SSH. That is it. The only inbound ingress protocol that's going to be allowed over the virtual terminal lines into the HQ router is going to be the SSH protocol. All right, so we've got that taken care of, and so we've got some IP SSH, and this is kind of nice, right? You can see the authentication retries and the timeout. So we're going to say 60-second timeout if after 2 retries, authentication retries 2, right? So if there's 2 bad retries to try to get in, we're going to have a 60-second cooling off period before you can get logged back in. So we are at 75 out of 93 points right now, and that's the entire SSH section. That is it, right? So now we're going to go ahead and we're going to move on, keeping in mind that we still have to go back. We still have our Dynamic Nat that we're going to be taking a look at. All right, so let's go ahead and look at DHCP. So on branch 1, we've got some DHCP work here, and let's come out here. So we're going to exclude. I like the fact they put this right away, that you don't have to bail out of your DHCP config to make this happen. So we're going to say DHCP excluded address. So the first 10 IP addresses in the range, and we're only dealing with the sales VLAN here, right? Only dealing with the sales VLAN. And the name is going to be case-sensitive VLAN 20. So VLAN 20, it's a 24. So the first 10 would be 10.1. Whoops, 10.1. I did it again. 10.1.20. Boy, oh boy. 10.1.20.1. And that's our low end. And then the high end, we're going to do the first 10, 10.1.20.10. That's our first usable 10 IP. So we should see 75 on our score, kind of shift maybe a little, and it does. So we're excluding the first 10. And IP DHCP pool is going to be VLAN 20. Now, there's a few things that we need to get sorted out here in the pool. We've got a default router value. Now, do they ask for that? Include the DNS server attached to the HQ LAN and configure the sales PC to use DHCP. Okay, good. So take a look at this here. They don't really tell us a whole much. They say the pool name is VLAN 20. Well, remember, hosts that are getting IPs in this range, they're going to need to know what their default gateway is, or else they will literally be limited to sending traffic only to hosts that are on their same VLAN. So what do we do here? Well, we're going to say default router is 10.1.20, and what would the value be? We know what it is because we configured it. Exactly. 10.1.20.1. That's the IP that we put on the gig00.20 sub interface, and we should also see a point, and we do, right? So that's our default router. We know what the DNS server value should be. It should be this server here, and do they give us? We don't get that information. All right, so let's, and we can't configure, so it's got to be, so that means someone else has got that information. So the production network, they must have. Can't get it on there. Let's check here, and it's gone. It was there, and now it's gone. So, and I may have wiped that out by mistake. So is the DHCP value up here? And it is not. So we may be in a little trouble here. All right, so here's what we're going to do. I can't get onto the ISP DNS server. It's got to be a 209.165. So we're going to hold on that point for right now. Let's come back to Baker 1. So here's what I'm going to do. I actually have, and give me just 1 second here. I've got a virtual machine running on another PC that I have that I can access hopefully in short order here. I can access this activity. I think I've got this activity. At least I hope I have this activity. Where are we at? Version 6. CCNA, connecting networks, version 6, and I do have the activity. So give me 2 seconds here. And in fact, while that's coming up, let's get the other statement we need in here, which is going to be the network, right? So for which network am I going to be, oops, sorry, we don't want that, we want 0. For which network am I going to be providing IPs, knowing that I'm excluding the first 10. So 10.1.20.0, 255, 255, 255.0, we should get a point. We got 2 points for that. Packet tracer still coming up, so I'm going to wait out. I'm going to wait it out here because the DNS server value, we're definitely going to need that value. And so we'll give it a second. Let me double check here. And so the PC is going to be the next thing that we configure. I don't want to do that yet until we have that DNS server, because I'm assuming that part of the validation is going to be that we're going to go to cisco.pka, right? And we're going to try to get there using www.cisco.pka. And packet tracer is still on its way up here, so just give me another second. Let's see what we've got next. Access lists. All right, so the access lists are probably going to round out the points that we are going to be looking at. Okay, I've got the activity up here. Let me pull up PC, or the admin PC, to get this value. And what is this value? And 10.0. That can't be right. 10.0.1.4. Let's see if that's what it was looking for. 10.0.1.4. I'll be shocked if this bumps me a point. And it does. Okay, that is the value. So I actually had to pull up packet tracer on another PC here. All right, so we're done with our DHCP configuration. And now let's go ahead and let's go to the PC for sales and to the desktop and to our config. We're static. There's nothing. Is this going to work? We should get a 10.1. Outstanding. Fantastic. And we've got the right DNS server config in here. Now, we don't have NAT configured yet. So we're still going to have to work our way through that. But for right now, we're good. Now we get to the, and yeah, there it is right there, asking us to go out to those web servers. So now we're down here to the ACL. So let's pull up the HQ router. And this is where we're going to be doing that. And it looks like, not sure why, show IP BGP. Okay, so we're up. I'm just checking it. We got that message there. All right, because HQ is connected to the internet, configure and apply a named ACL called HQ inbound in the following order. Again, so right, it's kind of nice that they're giving us the order here into which things are going to be configured. So here we go. As soon as you see BGP, is this going to be a standard ACL or is this going to be an extended ACL? All right, this is going to be an not a standard ACL here, right? Because we're going to be dealing with some layer 4 information. So on the HQ router, allow inbound. So let's go ahead and we're going to say IP access list extended. And then we're going to put our name in here, which is HQINBOUND. HQINBOUND. I'll make sure we're not losing any easy points here. All right, so in this order, allow inbound BGP updates for any source to any destination. So we're going to say, oops, sorry. We're going to say permit, got a little ahead of myself, and you can see they list some things out here. So BGP, right? They tell us it's TCP, so we would not say IP, and there is no BGP listing here, right? There's no, at least with what we're seeing in Packet Tracer. So I'm going to say permit, and it's going to be TCP. Now, from anywhere to anywhere equal to what? And they give us the port, right? So we're going to have to sort. There's a little sorting that needs to be done here. We've got to sort some things out. So equal to 179. So permit TCP any equal 179. So we should see maybe a point now. It might be a point once we're done with everything, but let's find out. Allow inbound HTTP requests from any source to the data center network. And that network is listed up there. It's at 192.0.2. So we would say permit TCP from anywhere to, and it's not an individual host. It says the HQ data center network. So 192.0.2.0, and remember, this is a wildcard mask here for our 24, for the /24. Are we done? If I hit enter right now, I've just opened up SSH connectivity that can now try to come through and get to the HQ data center. I've just opened up FTP, right? So any TCP, Telnet, any TCP-based protocol, if I hit enter right now, is going to be allowed through, but that's not what we want. Remember, we're talking about just HTTP. It doesn't say anything about HTTPS, only HTTP. So what's our keyword, right? Equal HTTP. So there's our second statement. You'll notice we're not getting points now. My guess is when we exit from the named ACL configuration mode that we're probably going to get a flurry of points. Our third statement says, allow only established TCP connections. And man, boy, I knew that they were going to come back and get us here with the established keyword. So we're going to say permit TCP, and it says allow only established TCP connections from the internet. So from anywhere to anywhere, and then what's our keyword? Established. Now, a quick point, again, I want to make sure we clarify this here, because this, again, this was kind of Cisco back in the day. This was their initial attempt, right, at doing sort of a stateful version of an ACL. Because remember, when we say we're permitting TCP any, think of it as like right in between the any and the established, we've got this little statement that if and only if it is already established. And so what that means is that we are going to be looking for acknowledgement packets or a packet with a reset in it, right? That is it. That it's got to have the acknowledgement, because that would indicate that if we put this ACL here on this interface, and let's say that the outside host, right, this guy is a bad actor. I can't do a skull and crossbones, so I'll just do an X. I'm terrible at drawing and art. So if he tries to SSH and he's trying to get to that server there, what is the first packet in a TCP sequence that we would see? Yeah, remember, it's all about TCP now when we're trying to understand what this established keyword means. It means that, and I think I wanted to say SSH there, it means that if this outside host tries to SSH through to the HQ data center PKA server here, that if it's not established, it's not going to be allowed through. And it would only be established if this was an ACK packet coming in, right? What's the first packet? Yeah, it's the SYN. So outside host tries to SSH through. Not going to get through because it's not already established. He tries to FTP through. Not going to get in because it's not already established. He initiates a telnet, initiates an FTP, initiates an SSH. Not going to get through because the first packet in the TCP sequence for all of the initiated, he is the initiator here. All of those initiated connections, the first packet in the TCP sequence is going to be a synchronized packet. It is not allowed through. it will be dropped. So you're probably saying, well, wait a minute, what about the HTTP? Remember, we put these in a specific order for a specific reason. This is going to be in a sequence number, an access control entry sequence number before that. So outside host tries to get to the website www.pka. Yes, bingo, it will work, because this rule says TCP from anywhere to that subnet if it is HTTP. It doesn't say if it's already established HTTP, and if you think about it, that doesn't make much sense. Because would it be established already if people out here are trying to establish HTTP connections to our web server? No, they're going to have to be allowed through in order to make that established connection. So the SYN packets in the TCP sequence are going to have to be allowed through for the HTTP, and that's what we did here. Now we're covering our tracks saying any other TCP sessions, if they're not already established, will not be allowed to come back through. And what is that setting us up for? I want to clear the screen here. So when we apply this ACL here, what is that setting me up for? Yeah, if I'm on router Baker 1 and I SSH out, right? And we establish, because now the SYN packet goes out and the SYN ACK is what is going to come back in. The ACK is in there. The ACK is allowed to come back in, right? It's going to establish that, because then I don't need an ACL in the outbound direction. So it prevents a couple things. It prevents me from having to put an ACL here in the outbound direction to allow the TCP out, because everything is going to be allowed outbound by default. So I don't need to worry about that. And I'm protecting myself against people trying to establish SSH or FTP or telnet connections, which could be nefarious, right? But I'm allowing that if the connectivity's been allowed out, that it's going to allow that connectivity back in, even though we're not, saying FTP, SSH is allowed back in, telnet's allowed back in. No. If it's established, that's my catch-all, right? And that's why we're using that. And again, this was something that Cisco used early on, and all it's doing, it's checking. Is it an acknowledgement that's coming back into me? Because if it's not an HTTP packet that shows up with a synchronize, right, it's dropped. If it's TCP, it's going to get dropped. And that's why we need this. So permit TCP any established. Allow only inbound ping replies from the internet. And remember, you're probably saying, well, wait a second, you just said TCP if it's established, then when we ping out, wouldn't that be established? Well, think about that. No. Remember, does ping use TCP? It doesn't. And you'll notice they conveniently left out, it doesn't say allow inbound ICMP replies from the internet, because that would give us the answer. That would make it maybe a little more understandable, right? From that perspective. So remember, ping does not use TCP. It's using ICMP. So we're going to say permit, right? I'll do a question mark. You'll see it's here. ICMP from anywhere, and it says allow only inbound ping replies from the internet. So from anywhere to anybody. It doesn't say just the HQ data center. It doesn't say just HQ1 or branch 1 or new branch, right? It says anywhere, right? From allow only ping replies from the internet or inbound ping replies. And so here's where we get down to permit ICMP any echo reply, right? So we're not allowing echo requests to come in. We're only allowing the replies to come in. And then it says explicitly block all other inbound access. So there's a difference between implicit. If I type exit right now, I'm allowing the ACL to implicitly deny all other traffic that I have not explicitly, further up here, all those commands, the permits that we were adding, I'm basically saying implicitly that I'm going to go ahead and block everything, right? So I've got this, I've got this ACL. We've permitted some things, but now the ACL is saying, I want you to explicitly say deny IP, or actually I think we should be able to get away. Yeah, deny IP any, right? And that should deny everything else. And now I'm going to hit enter, and we should get a flurry of points here and move off the 81. And, well, we got a single point for that. Okay. So deny IP any, and that's going to block all other inbound traffic that would be coming in to this ACL. Now, we need to make sure we apply the ACL. You'll notice it didn't say anything about applying it. So they're probably hoping that we're going to forget to apply it. But here's what we're going to do. I'm going to go ahead and we're going to test right now. Let's go ahead and test with, and what are they going to do from PC, from each PC? So we lost the IP information here. Actually, I have the IP information in this other window. Give me 2 seconds here. Let me look back over here at the PC, the admin PC. All right, so the static IP on this guy was 10.1.10.11, and it was a 255.255.255.0, 10.1.10.1, 10.0.1.4. All right, so we've sorted that out. So let's go ahead and give it a try here. Let's try, and actually we need our NAT to get out. So we're going to have to do the NAT. So let's do this. I'm going to do the NAT configuration. I'm trying to approach this in a semi-logical approach here. So let's do the NAT, and let's confirm that it works. Then let's apply the ACL. So let's get onto the HQ router. Now we're going to be forced to tackle NAT. And where was that at up here? Where was the NAT? Oh, way up here. Okay, NAT. So here we are. So now we're going to configure our NAT, and we're on the HQ router. So let's do this. Allow all addresses for the 10.0.0/8 address space to be translated. Okay, well, we know that that's going to be who are we matching? Who are we going to permit and allow to use NAT? So that screams ACL, right? So, and standard ACL. So, and actually, are they going to dictate? They want a named ACL. All right, so IP access list, standard, and the name is just simply NAT. All right, so what are we doing here? Well, we are going to permit 10.0.0.0, 0.255, 255, and this is a common mistake. Remember, we're allowing the /8 in, and that is a wildcard mask. So we want to make sure we get the wildcard mask correct for that /8. And I'm just looking up here again to make sure. So there's our ACL, and we get a point for the ACL, and that's nice. Okay, so XYZ owns the 209.165.200.240/29 address space. The pool. All right, so let's do this. IP NAT pool. And I know they're going to want the pool to be named. Okay, the pool HQ. So we're going to say IP NAT pool HQ. And here's where we would put the starting IP. So we own this publicly routable IP space, 209.165.200.240. Oh, sorry, 240, not 249. 200.240, and it uses 241 to 245 with a 29 mask. All right, so this is going to work. 240, and then it wants the end IP address, and that /29 is going to give us 6 usables, 241 to 245. So I'm actually going to have to work this out. So I can't do it in my head right now. So let's see. So it's 240, and so we've got how many host bits left over? 3. So we've got a block size 2 to the 3 of 8. So it would be 240 to 248. I should have been able to do that in my head. So 247, and actually, wait a second. So 241 to 245, 247 would be, yeah. So here's what we're going to do. I'm going to change this statement. So we're actually going to do this. We're going to say 241, because not every IP in there, obviously. And let's see, there's 2 ways we can do this. How are they going to want this? Let's try, well, okay, we'll try it this way first. So 241, and then the end, actually we'll do this. 241, and then 209, 165, 200.245. And then it's going to want the net mask of a 29, which is going to be 255, 255, 255, 248. Let me make sure I've got that. Is that right? 250, 29 is going to be 1, 2, 3, 4, 5. So 128, 192, 224. Or no, it's not. 240, yeah, 248. All right, so 248. And that should be the NAT statement. Let's see if we bump. And it looks like we did. So that should be correct. Again, the other way to do it is you can put the network ID and the broadcast address in there, but I wanted to see if they wanted it like this first. Okay, then bind the NAT to the ACL. So how do we do that? Pretty straightforward, right? So IP NAT inside source. Oh, I'm sorry, not source. Yeah, that's right, source list. Source list and this is the name of our ACL, NAT. So here's how we bind it to the ACL. So we bind the NAT pool to the ACL, and I'm forgetting something. It's HQ. Whoops, IP NAT inside. And do I have to say pool? Sorry, left off the pool argument, HQ. And that bumped us a point as well. So we've bound it to the pool to the HCL, and now, let me make sure I've got this right. Configure PAT. All right, so we are going to overload, and that's the sneaky part here on this one. The connections to the Internet HQ are outside XYZ Corporation. So hold on a second. The connections to the Internet and HQ data center are outside XYZ Corp. Okay, so we're going to be doing IP NAT inside search. So the IP NAT outside is easy. So serial 010, IP NAT, that's the single outside interface. It's this statement here that they've got the connections to the Internet. Oh, I see what they're saying. Okay, I see what they're saying. So we're doing it for the 10, so there's going to be 2 outside interfaces. So the HQ data center is considered outside. I apologize. I was like looking at that, and I'm like, what are they trying to say? All right, which means that everybody else, right? So my interface gig 00 is going to be IP NAT inside. My serial 000 is going to be IP NAT inside. My internet serial 001 is going to be IP NAT inside. And so that should do it. So we are at 90 out of 93. Do show run. And I know that I still have, we've got one thing left to do. And that's the application of the ACL that we created. I just want to look here real quick. All right, so let's see. Does everything work like it's supposed to? So let's go to http://www.pka. Can I get to the website? So from PCA, it doesn't appear to be working. Should be able to access the web page, outside host. All right, and again, with no ACLs, it's the Wild West on there. It's wide open. So let's try www.cisco.pka. Interesting. Okay. Oh, so the data center. Okay, so I can get out the outside interface here. And I can get to Cisco PKA, but I couldn't get to the data center. So we may need to take a look at something here. Okay, so I can do that. Let's go to the outside host. Can the outside host get to http www.pka? Let's see how the outside host fares here. Huh. All right, so the NAT is working, and I'm able to hit the public site from the outside. Okay, but we couldn't. Let's try sales. So we should be able to get to http www.pka. And that was the public site. Can I hit the private site here? Request timeout. All right, so we're having trouble getting to the data center. http:// And let's try www.cisco.pka. This should work, and it does. Okay, good. So I'm confident that we're good there. Getting outside www.pka. Okay, but we're not getting to the data center. Request is timing out. All right, so let's do this. Now let's go ahead and let's make sure that it's not waiting for the application of the ACL. So here we are in HQ, and let's say do show IP access list. So here it is, HQ inbound. We're allowing BGP. We're allowing traffic to go through to the public site. Anything that's established, ICMP echo replies and deny IP any. In fact, before I put that on there, let's make sure. Can we get to 10. What was it? 1.0.4? Let me make sure that's the right address. 10.0.1. I'm sorry. Ping 10.0.1.4. I'm seeing if we can get to the DNS server. All right, so I can get to the DNS server. Huh. All right, so let's go ahead and let's put this ACL on here. And I don't think we're going to get serial 010. All right, so here's where, and again, we had another activity earlier on. This is where it's the IP access group, right? Remember, and then the VTY lines, it would be access class. Here it's going to be access group. So IP access group, HQ, let me make sure I spell this right, inbound. So we're going to see some points for this. I don't think we're going to see 3 points for this. Oh, sorry. As I'm looking, I turned immediately instead of looking at putting it in the inbound direction there. Yeah, so we get a single point for that. So there has to be something that we overlooked or that I overlooked here. Let me take a look at the interfaces here again. Do show. Let's make sure that I've got the IP NAT inside outsides correct. Gig 00, that should be IP NAT inside, that's correct. Gig 01 should be IP NAT outside based off that statement in the Nat Configuration portion that says Internet and HQ data center are outside XYZ Corporation. So that is correct. Serial 000 should be IP NAT inside. That's correct. Serial 001 should be IP NAT inside. And 010 should be IP NAT outside. So it's two simple things. And let's not reset the activity. Let's check results real quick here. And let's see what it is that we overlooked. Oh, and they did do it to us, didn't they? All right. Okay, the VTY lines. So I know exactly what we're missing here. Yep, I know exactly what we're missing. So my apologies. The optimize keyword is going to bite us here. Whoops, we don't want that. We want this. So that optimize keyword is going to come back to bite us. And the VTY. So we'll take care of the VTY lines first. And where was it on the SSH? Where did we do the keys? On Baker 1. Where were the keys? On HQ. All right, so on HQ, if I say do show run, and I'll show you what we're missing here, we created a username specifically to be able to check to see if we could access HQ via SSH. What I did not do is it says login, right? But there's no definition as to do they use a radius server, a TACAC server, or the local AAA database. Line VTY 015, and I'm going to say login local. That should get us to 92, and it does. Okay, so that's the first piece. Now, the second piece is EIGRP here, where it says configure and optimize HQ and B1. So that routing comment that's in there, my guess is it's going to be here on Baker 1. So when it said route 0, what it really means is that something's wrong with the network statements that we've used. And maybe it's as simple as that. But that's typically, you remember we talked about this here, right? So let me see, did they want me to leave it? And what do we have? Just passive interface. So because there's a number of ways we could do this. So I'm going to do this. No router, EIGRP 100. router EIGRP 100, right? And so that's going to get us, and did I have passive interface default in here before? Yeah, so that's what we'll do. So I'm going to say passive interface default, and that should get me a point to 88. Then I'm going to say, or put us at 91. Okay, no passive interface, and obviously we would want no passive interface on, and let's double check this, maybe that's wrong, 000, but I think that's right. Do show IP interface brief. Is that the right interface? Yes. So no passive interface, serial 000. And we should see a point for that, possibly, maybe not. So because that's the interface out which we're going to be establishing this connection. So do they want, do show IP EIGRP, do show IP protocols. Let me see if we've got, so automatic summarization is disabled anyway. So if I say do show run, so I don't need to add that in there. So that wasn't the problem, right? We don't have the passive interface or the no auto summary, but that's not the issue here. The issue is the network statements, right? So they didn't want that overarching network the network 10.0.0.0. So let's try this here. And again, we had all these sub interfaces, and actually we had all these sub interfaces on branch 1 that are passived. So we were going to scoop them all up with this sweeping network statement. So what about this? So do show IP interface brief. They didn't like the 10. Do we get a point if we do this? 10.255.255.0, 0.0.0.3. So this is going to bring the link between HQ and branch 1 online. Does it give us a point for that? Does it like that approach? It brings the adjacency up, but the points don't move. And so I'm hesitant here to say that that is what they want. So let me do this. Let's say no network. Take these. Are they, maybe they're looking for us to say auto summary. Do show IP protocols. Let's make sure auto summary is enabled. And then, is that what they want me to do? No, so we still end up at 91. Yeah, because I'm not confident that that is what they want. So let's see what we have here. Do show run, and we're going to work through this. So let's say no auto summary. Huh. So the no auto summary puts us at 92. And I'm wondering, they can't possibly want us to do summarization here. Because this is the same behavior that the other activity showed. So we've got passive interface default. They like that. We did the no passive interface on the serial 000. That's the only interface that it makes sense to do that on, and we did it. EIGRP is 100. We disabled the updates with the passive interface, unless they gave us points. Let me see, passive interface, gig 0. They didn't give us points for this here. And they shouldn't have to. See, it's something where we've got it working, right? And things are correct, but it's that the packet tracer doesn't like the approach that we're using. Because if I were to go there now, and it's funny, it took us down to, and maybe that's it. Let's do it like this. So we'll say no router EIGRP 100. Router EIGRP 100. I'm going to say passive interface gig 00.10. Do we get a point? Okay, so that's it was the exact same behavior. So look at, we're now being given the points for passiving these sub interfaces. So instead of saying passive interface default, and does that put us at 91? Oh man. So that puts us at 91. So that's what they wanted. And now the question becomes, do show run? And again, there's more than one way to do it. Unfortunately, this is a little painful trying to sort this out. So no passive interface, no, and I won't say no auto summary yet. So let's put network 10 dot, 10.0.0.0. And do we get to 93 with that? That puts us at 92. So let's pull that out. 10.0.0.0, 0.255.255.255. Was that what they were looking for? So that gives us a point. Is it the no auto summary? Although that's the default. Okay, well, let me check. Oh, whoa, 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 whoa. Don't want to reset there. Sorry about that. I want to cancel that one. Check the results. Okay, because it's back. It's got to be that route. Yeah, so here it is. Oh, I'm sorry. On HQ. So HQ is having the same issue. I thought that was under the branch. So it's got to be on HQ. So here we are on HQ. Do show run. And so again, it's going to be something here in, and I went right by it, didn't I? In the EIGRP config. So it doesn't like, and my guess is it didn't like my passive interface default and then the serial on B1. Did I say, what do we have in there right now? Yeah, so I specifically passived. It's got to be, that's got to be it. Okay, let's say this. Let's go to exit, no router, EIGRP 100. So router, EIGRP 100. And is it looking for me to literally passive individual interfaces that we're going to be announcing? And the network statement is no passive interface serial 000. So that should get me a point. And then the network statement, let me check and see what we had in here before real quickly. So passive default, no passive, and then the network statement. So no passive, serial 000, and then the network statement is going to be 10.255.255.0.0.3. And it doesn't like that either. So then let's do this. No router EIGRP 100, EIGRP 100, router EIGRP 100, and we're going to go ahead with passive interface. Let's watch. Do we get a point for passive interface default? We get 2 points for that. No passive interface, serial 000. And that doesn't get me the 93rd point, so it's got to be they didn't like the network statement. Are they looking for this instead of something specific? Oh my goodness. Okay, so, whew, that was a tough one. Okay, so here we are. That is what they were looking for. An all-inclusive network statement, the no passive interface and the passive interface. So we're at 93 out of 93, but did this solve the issue of us being able to hit www.pka? And again, I'm not positive or confident, yeah, that it timed out. Okay, so it timed out, but we can get to it from the outside, right? We put the ACL on there. Can I still get to www.cisco.pka? Is that the inside? I'm sorry. www.pka is our inside. There we go. And so we can still hit that, right? Still working. In fact, if I were to go to the HQ router and say, do show IP access list. Take a look, right? Looking good, right? 45 matches. Everything has been established, so everything looks good. All right. Well, we are at 93 out of 93. This was a monster activity. This is going to be a long one, folks. And again, thank you guys for watching. Hopefully this clarified any issues that you had. You've got a much better understanding of all the technologies that we've worked on in this class. Again, this is the final packet tracer activity for CTS 231 841 section 841 for the second 8-week term of the fall 2017 semester. All right, make sure you guys study hard, stay safe if you're out in the snow, and I will see you all on Tuesday night.